So powers, that's what we're gonna learn. Uh, do you understand the meaning of powers or power? We also call it exponent.
Yeah, I know.
Yeah. So what is the power of that number right there?
1.
Yes. So if it's not written there, you can write 1 on the top of that. That's true. Um, some people, they mistaken it to 0. Their answer will be, when x says there's nothing, that means it's 0. But then when you have 0, the whole thing is gonna turn into 1. Any number powered by 0 is 1. That's a different case. We'll understand it later on. X squared means x multiplied by itself how many times? Too many times. Now the question is, what is the difference between these two things? How are they different? 3x whole squared and 3x squared.
This is like multiplying both of them.
That's right. That squared is 4, 3, and 2. 3 squared x squared. And here we have power, but that is only acting on the x. There's no influence on that. It's the 1 power, the 3's power is still 1. Right? The power of 3 is 1, but this 2 distributes on both of them. Or you can also call it that becomes 3x multiplied by 3x, number times by number, and x times by x. So 9x squared is the simplification of that, right? So you can distribute it or multiply inside these many times, too many times. Clear enough, right?
Yeah.
Now, the next thing that they're talking about is how we can add them now. They're teaching you the square root on the same time. So these are second degree powers. Degree means maximum power, by the way. We can have the powers like cube, 2x, y cubed. That means cube means third power. So you're gonna raise 2 by 3, x by 3, and y by 3. You distribute this power on all of them. And what is the power of 2? That is just 1. If there's nothing, that is always, we assume it's 1. So 3 times by 1, 3 times by that 1, and this 1. And you're going to get 3, 1 times 3, 1 times 3, 1 times 3. So that is that. Now you can expand it. Simplify that. 2 cubed means 2 times 2 times 2, which is 8. Here we go. Now, next thing is adding or subtracting powers. Adding. Now, how do we add the powers? For adding them, for example, 3x squared minus 4x squared, let's say plus x minus 3x. Now, let me call it y. Y equals to this whole thing. Y is that term minus this term plus that minus that. Now, in order to simplify this thing, if they simply ask you to simplify this whole thing, what are we going to do?
You're gonna find same exponent number.
No. Oh, yes, same exponent. That's right, same power, right?
Yeah.
Like that. Now, x squared is a common thing between them, right? They're looking same. These are 3 of x squared, and those are negative 4 of x squared. So we add up or subtract the like terms. What would be that? What would be the answer of this subtraction? Negative 1 and
X.
yes, you can write negative 1x squared. And there,
Um.
negative 2, but you're not telling me x. We must write x afterward. Afterwards, we write x, and now negative 1 times by anything, 1 doesn't affect anything, right? So it's gonna be x squared. And this minus stays at the front. Did you know that? So minus 1, you don't have to write 1 because 1 times by, for example, 1 times by 4, what is that? 4. 1 times by 7 is 7. And minus 1 times by 3 is going to be 3, but negative sign stays negative. So 1 doesn't affect x squared because 1 is just a unit, right? 1 times by anything, that number is going to stay as it is. 1 multiplication doesn't change the number. And that is negative 2x, right? That's the adding or subtraction of these kind of like terms. So we always add and subtract like. What we call like when the powers are same, variables are also same, like x, and squared, then they can interact in the same manner right there. The x terms and interaction can happen, or we can add, subtract them. So we learned that square of this number is 4, and square root of 4 is gonna be 2. Now we do one more example. What is now which number is gonna be in the bracket? Square root of what number is 9?
3.
And if I do this thing, what does it mean? That means reciprocal. I mean, not a reciprocal, kind of opposite relation. So we call it square root of 9. Square root of 9 is gonna be 3. Right. The second way of understanding it. Now, when I say square root, they don't teach this thing in grade 9 sometimes, but let me write it here. Square root of 9, that's a radical, that part. And as I already explained to you, you can also write 2 there. For cube root, you're going to write cube here. For example, cube root of 12. Right? So now that is the square root. We're going to convert it to the exponent. This radical form is equivalent to 9, and square root becomes 1 over 2. One more example. Square root of cube root, cube root of 8 means 8 powered by 1 over whatever is there as a third. This number is 3, tiny 3. So write over 3. So that's a conversion of radical to exponent. And you can simplify this thing as well. Let me show you how we simplify that. Now 9, you know that 9 is 3 squared, right? So I replace 9 by 3 squared inside the bracket. Now that bracket stays there. The power is 1 over 2. Now the next thing, the powers multiplies. The powers multiply always. There's a power and then there's another power. Whenever you have a bracket and second power, third power, they always multiply. So what we're gonna do, we do 2 multiplied by 1 over 2. Now you tell me what would be that. 2 multiplied by, what is this thing? What would be that multiplication? 1. That's easy. Because 2 times by 1 over 2 means 2 over 2, which is 1. So we got 3 equals 3 power by 1. 3 power by 1 means 3. That means we proved square root of 9 equals to 3. And that way is exponent. We convert it to the exponent and then simplify that. Now let's do that one. I have cube root of 8. The cube root means 8 powered by 1/3. Right? The third is 3, so you write 1 over 3. Now the next thing is we have to get rid of this thing basically. That is the whole sole purpose. Here we got rid of this 1 over 2, right? There we got it. There's nothing on the top there. In the same manner, we're gonna do get rid of this power by writing 8 as a power of some number. And we already know that. I chose this example with some reason because I knew that 8 is 2 cube. Isn't it? 2 cube means 2 multiplied by 2 multiplied by 2, which is 8. So now what we get here, we write 2 cube, replace 8 by 2 cube, and the power is 1/3 outside. As we learned that powers multiply, so you do 2 powered by 3 times by 1/3. And with the same logic, let me write them a little bit smaller. Now what is 3 times 1/3? Yeah?
1.
Good. So 2 powered by 1, which is 2. So those were some special examples that I picked for you. I think you understand both of them. I mean, the way I turned them into exponent thing, and then I got rid of this fraction power. So that is the another way of thinking. The initial way was that squared 2 is 4. Therefore, this implies that square root of this guy is gonna be the green, right? The square root of 4 is gonna be 2 because 2 squared is 4. That's the simple logic. When we start, we go with that simple logic. Now, can you answer me these things? Square root of 4
Is 2.
square root of 1,
Is 1.
square root of 3,
1.5.
1.5, probably 1.7, but we don't have to know that because we are just doing things with the logic. So that's a calculator that evaluate. We can also do it with the hand, with the pen and pencil on a paper. We can write it down. There's a procedure, there's a process of doing it without calculator, but they don't teach you in Canada, so we don't have to learn that because we have the machines to evaluate those things. But the approximate number, this is an irrational number. This is an irrational number, and How about square root of 2?
1.
1.414. That's the approximation.
Oh.
That is also irrational number. So they are not whole numbers. They're not whole numbers. Same that one. We call them irrational numbers because they're not whole numbers. Any radical form which is not a whole number, we call it irrational numbers because you cannot write them in a fraction form. That's another like advanced level mathematics. You're gonna learn that thing eventually. So that was a review for square roots and the powers for your exam. So that's what we covered so far. Sorry.
The paint's coming off.
Yeah, let me have a look at that.
Can this recorder like go full screen?
Next topic, multiplication of powers. That means, for example, 2 squared multiplied by 2 cube. Now we know that if you want to do it without any formula, you simply do expand the 2 these many times. So you multiply this number 2 many times, which is 2 times 2. And there is a multiplication sign, and you multiply 2 3 many times. So we got, how many numbers are there? 5 numbers. So we got 2 raised by 5, and even you can write the simplification of that. That number is equals to 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 6. Yep. So you can also write it equals to 32. But that number or the multiplication in power form is that, right? That is also 32. So equivalence of the powers, whenever you have the same base, the base means that number, this thing, right? Whenever you have the same number here, you can add those powers. Got it? So in the same manner, so rather doing it, now we multiply them. Rather multiplying, you could have simply added them, like 2 plus 3 is 5, right? So we can skip all those steps. Now next example, 3 2 times by 3 4. 3 powered by 2 times by 3 powered by 4. What are we gonna do in this case?
Add them up.
Good. So we don't have to repeat this whole thing. We don't have to expand it. Simply we learned that we can add up the powers. So your answer is gonna be 3 raised by 6. Now that was multiplication. In the same manner, whenever you have same base, you add their powers. Now the division thing, dividing the powers. Division. It's the same kind of thing. 2 powered by, for example, 7 divided by 2 powered by 5. Now if you don't want to use the formula, you simply expand it. 2 7 means 2 multiplied by 2, right? 7 many times, 1 2 3 4 5. And then you divide it by 2 times by 2 times by 2 times by 2 times by 2. Now you can cancel the numbers. We simply see that if you divide top and bottom by 2 2, we got rid of one of 2. Then keep doing it. Keep doing until they keep cancels, right? And your answer is gonna be 2 powered by 2. keep dividing numerator and denominator with the common factors. The common factors are going to be 2, 2, 2, 2, 2. So your answer is going to be that one. So that's a long way. Shortcut is going to be subtract the powers. Now let's do the shortcut. Rather doing this whole thing, you could have done it that way, this way. Whenever your base is same, now base is 2, 2. They're same. That means you can subtract, then you subtract the powers. So once again, whenever there's a division, that line means you're dividing it by that whole thing. Whenever there's a division and the base is same, you subtract the powers. Now you want to write the number as a non-fraction. That means you subtract 5 from 7. Let me clear one more thing. Let's say 4 powered by 1 and then 4 raised by 2, or 5. Now you can write it in either way. That means, what do I mean either way? You can do 4 1 minus 5, or you can write it like subtract this 5 from 1 from that 5. That means subtract the power of numerator from the denominator. Both ways it's right. You can subtract the top from the bottom, but you have to write the answer at the bottom in this case. And if you subtract the bottom from top, then it goes on the top. You know what I mean? Your bottom is 1. Here your top is 1. And so that is 4 powered by 4. What is that? What is this thing? Negative 4. You're going to write over 1, but 1 is not affecting it. Here 1 is important. It's a fraction, but there 1 is not important. So you can write it as 4 powered by negative 4. So what does it mean? That means this is same as that. So you're going to remember, whenever you have a negative power, this negative sign is going to cause a flip. So that number flips 1 over 4, 4. So we learned something new, which is, I'm going to sum up with one more example. So we learned, come here. We learned that 3 raised by, for example, minus 1 is equals to negative sign flips it. That means the reciprocal of 3, and the power becomes positive, right? So 1, you can write 1 up here if you want. 1 doesn't affect anything, so 1 over 3. So any number's power 1 doesn't change the number. Now 4 minus 2, that is equals to 1 over 4. As we learned in the previous case, negative sign cause a flip, but the power becomes positive now. You see, negative 1 becomes 1. In the same manner, minus 2 becomes 2. Minus disappears and it causes a flip. So that's what we learned in this example right here. So we can expand it if you want, because power 2 distributes on both of them. So that is something that I didn't teach you. If you have two numbers dividing each other, this 2 is going to distribute on the top of both of them. 1 power 2 means 1 times 1, which is 1. 4 power 2 means 4 times 4. Good? Now you're going to answer me this question. Let's see if you understand the concept. What will be that? in a positive power form. If they ask you to simplify this thing, how would you do that?
1 over 5 brackets and 2.
That's right. And what is that? Now you distribute the power. That means both of the numbers. Now their powers is nothing. It's a 1. When you say that there's nothing, that means the power is 1. So the power of 5 and this guy multiplied by the power sitting out there. Yeah, 2 times 1,
So it's 1
2.
over 25.
5 power is going to be 2 as well. 1 power by 2 is 1. 5 power by 2 means 5 times 5, which is 25. So we learned that negative sign in the power do the flip, that means reciprocal, and becomes positive afterwards. Now let's do some questions. For example number 6y squared. Alright. I write it here. Now if you noticed, here we have a bracket, but there's nothing, no power outside. You see that? There's no power on this bracket, not on, so all the powers are inside. So what we do, in order to simplify this thing, you look at the numerator. We have, what is the sign between these two brackets?
1.
No, sign. Is it multiplication relation? Yes. If there's nothing, that means it's a multiplication. Sign between, so we don't have plus, we don't have minus. We have no signs, that means it's a multiplication. So how do we multiply them? We multiply a number with the number 6 times by 2. Let me do that slowly. I write 6, and in a tiny bracket I write minus 2. So that means this number multiplied by the number, and the powers, like the unknowns, unknown is y squared and y5. I write them afterwards, after these two numbers, right? And next is bottom. You don't need a bracket on this, because we use bracket whenever there's something out there, or whenever something is a power. So there's nothing, so you don't need a bracket. Now by using the rules that we learned, we do 6 times by 2, negative 12. And we just learned, if the base is same, you add up the powers. So we're going to add 2 and 5, 7. Why do we add them? Because the relation is multiplication there. They didn't write anything, that means it's a multiplication. At the bottom. Now, the next step is you divide 12 by 4. What is that? 3. And the sign negative stays there. And then you have y raised by 7 minus. Now why do I subtract the powers? Because your base is same. Your base is, in both cases, it's like y and y. Whenever your base is same, you subtract the powers. You subtract them. Good? So your answer is, what is your answer? Negative 3y4. Now you're gonna solve the next question.
Sure.
powers of powers. That means if you have some number, let's say 2 cube bracket 4. Now we have 2 powers. If you look at that, we have 3 and then 4. What's
So
gonna
do this first, get the answer, and do that.
Yeah, you can do that. You can expand them. That's right. There's nothing wrong with that. You can solve that power. Solve that power means you multiply 2 these many times.
Yep.
And then you talk about this power sitting out there. So let me do it the way you want. You want to multiply 2 3 many times, and then you want to do 4, which is basically 8. Now these dots means multiplication in math, and probably your teacher is also doing that way. So you don't have to write crosses. It's acceptable if you put the dots. Now we know that this is 8 multiplied by, not multiplied, powered by 4.
4,000.
Yeah, that means 8 times by 8 times by 8 times by 8 and 4,000, whatever, right? The number is, you're gonna write it here. Now that is a little bit bigger way of doing it. You can do it more quickly, and that is you can skip all those steps, right?
You just add them up.
Yeah, if you simply not add, if you multiply them, if you multiply 3 and 4, you can skip that hustle. So let me.
So 2 times 3 times 2.
Yeah, what we do, we multiply the powers whenever you have a bracket and another powers, they multiply 3 and 4, 12. So that is what we're gonna do in this section. We simply multiply the powers.
Yeah.
Whenever you have power of powers, you multiply them. Now
You
let's,
get the same answer.
yeah, the answer is gonna be same for sure. Let's do one problem. I'm gonna do C part. So now in here we have 2 brackets divided by a bracket. What do? We multiply 3 with -4. A is a same base. We add up their powers. We add up B's powers. Why? Because there's multiplication. So let me do it here. But before doing that, you have to deal with power. Always do, if there's anything on the top, deal with that thing. That means solve that part, and then we will take care of rest of the things.
Times 3.
So we do this power. We do 3, distribute this power, right? Distribute it on all those numbers.
So 27.
And 6
A.
there, right?
Yeah. 20.
And then bracket -4. That's just the same thing, because there's 1. There's nothing, that means power is 1. You don't have to write it, but that's 1 divided by that whole power 2. So that means 2 power by 2. 2 multiplied by 2 is gonna be 4. This power times, so you distribute means you multiply this power with all the powers inside. The power of 2 was 1, so we got this thing. Next step. In the next step, let me write here. I write, simplify that. 3.
Isn't it 3?
No, it's not adding. I told you, whenever there's a bracket, power of powers, they multiply. Whenever there's a power
Oh.
outside, you're gonna multiply that power with all the powers inside. Now, 3 cubed is 27. A cubed stays the same. And then bracket. Now, you can write this 4 at the front if you want. Let me write it at the front. I write all those numbers together. I write 27 bracket -4, then a cube, and that there's a squared, and then I write this b6. So I write together the like terms, or write them together. 2 power 2 is 4. Next step is multiply them. Negative sign. Now these two powers add up because base is same and there's a multiplication between them. Same with the b. 6 plus 1, 7. Now we divide that number by 4. It's gonna be negative sign stays, and that over 4 now they are dividing each other. So what do? Bases are same here, so we do a power by, and bases are b in this one, so b power by subtraction. We subtract the powers whenever there's a division. When there's a multiplication, we add them. That's we learned in the previous example. That's 1, right? You can write 1 if you want. That's not necessary. This is the answer. So now there are 2 things that you have to keep in mind. The first is this thing is different from that. Here you add them, and that is a power of powers, and there you multiply them. Multiply the powers, and here you add the powers. Base same is gonna give you that thing. Whenever your base is same, you add up the powers, and when there's a number, power, and then power, then you multiply it that way. So that is the difference between these 2 things. So I just noticed that you mixed them up, so that's why I cleared these 2 things. You can go to my website or the YouTube channel to watch this video that I recorded here. And yeah, that is that. I'll see you next time.